Okay, so continuing with the 2020 AOIME problem number 5. For each positive integer n, let f of n be the sum of the digits in the base 4 representation of n, and let g of n be the sum of the digits in the base 8 representation of f of n. Right about now, you're probably thinking, TF? Well, they probably know that you're feeling that way, so they're going to give you an example. For example, f of 2020, again, n would be 2020. We want the sum of the digits in the base 4 representation of 2020. Always try to process what you're reading. Don't just read it straight through. Go back and connect the dots so that you understand what they're saying. So we have to turn 2020 into a base 4 representation. Typically that's 133210 with a small base like this, but they decided to spell it out for whatever reason. So 133210 base 4, we want the digit sum, right? The sum of the digits of this number, this one written in base 4. So 3 plus 3 is 6, 3 more is 9, and 1 more is 10. And then I need to take that sum of the digits and let g of n be the sum of the digits in the base 8 representation of f of n. This is f of n right here, 10. So what do I do with it? I need the base 8 representation of it, which is 12 base 8. And then what do I do with that? I need the sum of the digits of the 1 and 2 in the base 8 format. So then it says, and g of 2020, again, that's still n, it didn't change, equals the digit sum of 12 base 8, the last thing we found, which is 1 plus 2 is 3. Okay, if we did that well, we should kind of understand. How do you get help with this content? There is no school math that's going to help you too much with bases, at least in the regular math core courses. If you take computer science, and most of you probably have taken computer science or will take it in the future, they do cover bases to some extent. And probably what they cover in that class is enough to do this. Otherwise, you'll have to teach yourself from another source. I recommend the AoPS number theory book. Sometime in the future I'll link it, but I'm not allowed to link on videos until I'm partnered with YouTube. So the number theory book gets into all of this kind of content and should make you a little more comfortable with different bases if you feel discomfort when you see them as of now. It's a great book, extremely well written. So let n, capital N, be the least value of little n such that the base 16 representation of g of n, again, g of n is the last result of that process, cannot be expressed using only the digits 0 through 9. Find the remainder when n is divided by 1,000. Basically find n or something close to it where we can accomplish the final sentence. What does it mean, not the digits? Aren't those the only digits? No, and I don't want to assume too much of your knowledge. I will explain some things, but I am going to kind of go through assuming you have a basic understanding. But for those of you who don't, I will explain this part. In base 16, you have the digits 0 through 15. Why do we have the digits 0 through 9 normally? Because we are in base 10. And the digits that are available in base 10 are all the numbers, the integers less than 10, the non-negative integers, 0 through 9. Those are the only ones you can use in a base 10 system. But in base 16, it's obviously 0 through 15. But how do you write, like let's say you had the number, 12 and you wanted to write it in base 16, how would you do that? Well, this is one digit, only one digit in base 16. So what they do to accomplish this is they let 10 usually equal the capital letter A, and then 11 will equal the capital letter B, and 12 the capital letter C. And you would write C base 16, that's equal to 12 written as base 10. Okay, so now that we understand that, that's kind of fundamental to continue, so I want to make sure you get that first. We want capital N to be the least value of little n so that this happens. Well, what is the first base 16 number that is not 0 through 9? That'll probably be the smallest one. That works out. That's going to be A, which is basically 10 in base 10 format. So A base 16. This is not a digit 0 through 9. I hope you would agree. So then let's see how this works. We got the sum of these two digits to be 3. That was g of n, that 3. And what we need g of n to equal is basically 10 is what it has to come out to, which 10 in base 10, but that's, as it says here, it's A in base 16. So then how are we going to get 10? We need the sum of the digits in base 8 to equal 10. This is really just a working backwards kind of problem, and you just take little baby steps until you get there, kind of intuiting the next step from the previous one. So if I need to get a sum of 10 from the base digits here, we're in base 8, which means we don't have access to 8, 9, or 10, or anything above 8, basically, or anything above 7, actually. So you have 0 through 7 to use. I'm probably going to do it with 2 digits in base 8, and I'm going to want to maximize this one, therefore it will minimize this one. So the maximum I can put here is 7. You can't go over that in base 8, and this is 3. What does this mean? Let's kind of refresh. 37 in base 8. Think about what 37 is in base 10. It's 3 times 10 to the first plus 7 times 10 to the 0. But in base 8, it's not 10 to the first and 10 to the 0. It's 8 to the first and 8 to the 0. So this is 3 times 8 to the first plus 7 times 8 to the 0 when we convert it to base 10 thinking. So 3 times 8 to the first is 24 plus 7 times 1. 24 plus 7 needs to equal 31. Well, where did we get this 30? Where did this 10 come from, right? This 10 came from the sum of the digits of this number in base 4. So what we need is the sum of the digits in base 4, right? Digit sum of some number in base 4 to be equal to 31. And again, just like we used the strategy of maximizing the right-hand digits, that's what we need to do here with this base 4. So in base 4, what digits do we have access to? 0 through 3. So this is the maximum digit that we can use. So what we want to do is make all 3's. How many do we need to get to 31? You're going to need 10. And so there's 10 3's here, and then we're not there yet. It's only 30, so we need one more. We need this number here, one with 10 3's. And then that's a base number down there, base 4. It's not part of the 1, 3, 3, 3. So where do we get this? We need some number that converts to this number here in base 4. So we're going to have to convert this back to base 10 because that's what n is in. It's in base 10. And that's not going to be too fun, it looks like, but don't panic. We got lots of time, 12 minutes per problem at least, sometimes more for later problems. Just go ahead and start converting. Again, if you notice, the second place digit was 8 to the first because the first digit is 8 to the 0. So the same thing's going to happen here. You're going to have 10 places. It's going to be 4 to the 0, 3 times that, plus 3 times 4 to the first. I'm going to move this out of the way. Going back this way, it's going to stop when we have 10 of these 3's, which would be 4 to the 9th, not 4 to the 10th. So we're going to have 4 to the 9th times 3. Why did I put it over there? I don't know. So 3 times 4 to the 9th. And then we're going to have, besides that, plus the one that was in front of all those 3's is going to be 4 to the 10th. So it's 1 times 4 to the 10th plus that expression. Okay, so now how do we analyze this? Well, let's factor out a 3 and see what we can think of. That's going to be 4 to the 10th plus 3 times 4 to the 9th plus 4 to the 8th plus ... plus 4 to the 0. Well, what is this? It's a bunch of powers of 4, therefore it is a geometric sequence. Now the sum of a geometric sequence, you should know this formula, is a sub 1 times 1 minus r to the n. The biggest mistake on this formula in memorizing it is people put the n outside the parentheses. Don't do that. So a sub 1 is our first term. So we'll use 4 to the 0 as the start. And so it's going to be 1. We got a 3 outside, don't forget later. So we're going to get 1 times 1 minus r. What's the common ratio? Well, it's multiplying by 4 each time because their power is a 4. So the common ratio is 4, and how many terms do we have? Don't forget there's actually 10 terms from 0 to 9, including the zeroth power term, is going to be 10 terms. So 1 minus 4 to the 10th over 1 minus 4. 1 minus 4 is negative 3, and we have a positive 3 right here, so I'm just going to kind of cancel over here to get negative 1. And then that negative 1 is essentially going to flip this around to become 4 to the 10th minus 1, right? Or negative 1 plus 4 to the 10th, which is the same thing. So now finally we will have 4 to the 10th plus 4 to the 10th minus 1, which is going to be 2 times 4 to the 10th. Convert this to powers of 2. It'll be 2 to the 20th times 2 is 2 to the 21st. Don't forget the minus 1. So 2 to the 21st minus 1. In fact, if you forgot it, you'll probably get it wrong answered by 1. All right, I need some space, so I'm going to clear over here out. Let's go from there. So 2 to the 21st minus 1. What do we have to do? That's our n, right? We need the remainder when that n is divided by 1,000. So if you've worked with modular arithmetic, we just want to mod out that number with mod 1,000. So you kind of can ignore the negative 1 and just take it off the mod at the end. And you really just want to mod out 2 to the 21st. This is going to be congruent to 2 to the 10th times 2 to the 10th times 2 mod 1,000. And then from there, we can mod out each of these terms individually. If you don't know what I mean by that, I'm not going to take the time to explain it right now. You really need to get the number theory book or watch some number theory videos that explain it. I don't have time in this video to go through it. So what we're going to do is we're going to take the product of these things when I mod them out is the same as the final modded out value of 2 to the 21st. So we know what 2 to the 10th is. You probably should. It's 1,024, half of the famous game 2048, which some of you probably played as kids. So 2 to the 10th is going to be 1,024, but you can mod this number out by itself, meaning get its remainder when it's divided by 1,000. That's going to be 24 times 24 times 2, and then this is still mod 1,000. Then what? The 24 squared is 576 times 2, doubling 500 is 1,000, double 70 to get 140. Let's just write it so we don't mess up. So 1,000 plus 140 plus 12 is 1,152, right? Now don't forget, that's only 2 to the 21st. We still have to mod this out, which means get the remainder of it, which is 152 when it's divided by 1,000. That's all modding out is getting the remainder when you divide by the mod. So 152, but that's not the end. Don't forget the negative 1. Don't be so anxious to get to the next problem. Subtract that 1 to get 151. That's the answer. And we're on to the next problem.